And back for part two of the GSF Day 2 transformations. Just a comment before we get on. Again, just look at this. It's a mess. It feels like, especially because it's a pattern, that we shouldn't need to show all these steps, that we should be able to have some sort of shortcut. So that's what we're kind of hoping for here. I'm going to go back now and skip some stuff that I missed before, and it's putting this business in here. And I'm going to copy the graph in there. It was 2 sine 3x minus pi over 2. And I'm going to write in the domain and range and amplitude and all this business. So this is the unstretched version. This is the black dotted one. What's its deal? Well, the domain is x is a member of the reals, right? All real values are allowed. It's not tangent, so it's not got any holes or anything. The range, of course, is from -1 to 1, right? Whether you want to write that in set notation like this or in interval notation, that's up to you. The amplitude of the original one was just the height of one bump, right? And before I stretched it, it was just 1. The period was 2 pi, right, which is the length of time, length of independent axis before it starts repeating itself, and it was 2 pi. 360 last year, but 2 pi this year. The phase shift of the original was 0. Right? I hadn't moved it left or right, and the axis was y equals 0. Axis, sometimes we also call it the average, by the way. We'll also call it the resting point for reasons we won't see until maybe we do some applications. The resting point. I'm also going to add one to your table here. I'm going to put in here important points, because that seemed to be a bit of a deal, right? And the important points for the unstretched graph was pi over 2, or every 3 ticks, right? And then when we start squishing it and stretching it and all this business, this changes, and in fact that's going to give us our pattern. All right, so the domain of the final graph, which was this purple one, remember? Well, still all real numbers. This is still all real numbers. But what was the range? Well, the range was, it went from -2 all the way up to 2 because it had been stretched. -2 to 2. Amplitude was the height of one bump. So how high was one bump? Well, it went up to 2, and we could have probably guessed that. And of course, one of the things we're looking for is, do we actually have to look at a graph to pick the amplitude and period and stuff like that out of the equation? And I hope not. The period. Well, there's a couple ways to think of the period. The period is, well, how long does it start to repeat? Well, that's 4 squares, and I know each square is pi over 6. So there's pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. 4 pi over 6, which is 2 pi over 3. Okay, dandy, 2 pi over 3. By the way, we could have thought of that a couple of more ways. One of them is the original was 2 pi, and we squished it by a factor of a third, and so of course it's going to be squished to 1/3 the period. That makes sense. Here's another way that makes sense. Another way that makes sense is, if I were to look, and I don't want you to mess up your graph now, and I hope, can we see the yellow? No, I can't really see the yellow. I'm going to use red. In 2 pi, that's from here to here, how many repetitions of the purple graph do I have? There's one. There's one repetition. There's a second repetition. Oh, there's a third repetition. So in 2 pi, I've got 3 repetitions. So what's the period for 2 pi divided by 3? That's yet another way to think of the period. Dandy. By the way, I'm going to talk about the important points now. The important points also got cut in a third. Where it was 3 ticks, now it's 1 tick. Where it was pi over 6, it's pi over 2 divided by 3, which is pi over 6 every 1 tick. And that's going to be an important way to think of this soon. Phase shift for this one, well, we went right pi over 2. And we think of pi over 2 as 3 ticks. What was the axis? Well, we didn't move it up or down, so it's still y equals 0. Okay, well, would it be possible then for you to pick things like the amplitude, period, phase shift, and axis out of any old equation? And can I get this, all this stuff on here? Can I get this on? Yeah, let's try that. Don't mess up your note, but I'm going to erase this so I can actually see what I'm doing. Don't mess up your note. Just so I can fill in this little chart. Well, if it's have all these numbers in here, what's the amplitude? Well, the amplitude is the A. Well, not really, because if it's a negative, we don't think of the height of a bump as being negative. So we would normally write down A, but we put absolute value signs on, so we know it can't be negative. What about the period? Well, in this case, we know that the B value here, the B value was 3, and then the period was just 2 pi divided by 3. The B was 3, and the period is 2 pi divided by B. All right, and also that goes with that, then important points occur every, because we know multiplying by B is a compression factor, 1 over B, 1 over 2 divided by B, or every 3 divided by B ticks. Not 6, that's a B. The phase shift, well, which one's the phase shift? This is the move left or right, and that's D, right? So we move right D units. And even though we didn't see one in this example, we will in the next one. This moves the axis or vertical displacement or the mean or the average or the resting point. All these things we use as the same up C. So, of course, this is outside of the rule affecting Y values. It moves it up C. I'm hoping we can use these facts to do this more quickly. All right? I'm actually going to fill in the chart and do the graph after and see if we can handle that. Notice there's a problem here, though. We've seen this a couple times. Ever since Unit 0, it's not quite in the nice form here, right? It needs to be factored on the inside here. So we'll factor this first so we can see what the phase shift is. That 2 gets factored outside. And notice when I divide by 2 here, I got to divide by 2 here as well, and it becomes pi over 4. Right? Divide by 2, pi over 4. This 2, it doesn't affect the 3. And now I'm going to write this in here and see if I can think about this graph before I get to the transformations. I'm going to see if I can skip right to the final graph without doing the individual transformations. Just watch me. Just like any coast graph, I can flip it and stretch it and squish it and move it up and down. It's still going to be allowed any real number. But what's the range going to be? Well, think of this. The range is going to be moved up 3. Right? I'm going to move it up 3, so kind of like the starting spot is going to be 3. This will be easier to see once we get to the graph. But then the amplitude is going to go up 2 from there. Up 2 from there to 5. And down 2 from there, the amplitude to 1. So what's the range going to be? 1 is less than y is less than 5. And notice this plus 3 is right in the middle of there. What's the amplitude? It's this 2 that's in front. What's the period? Well, the B value is just this 2 here. That's B. And so the period is 2 pi over 2, or just pi. So that means this graph whenever I get around to graphing it, is going to start repeating itself every pi units. Okay? What's the phase shift? Now that I've factored it out, I can see that it's right pi over 4. This is weird because my scale, a bit nasty there. I'm going to start drawing this one. I'll go back to the graph, but I just want to mention this pi over 4 business is a kind of a hassle. Because we do every 3 ticks is pi over 2, right? 3 ticks is pi over 2. I'm kind of counting that's pi. 3 pi over 2. Every 3 ticks is pi over 2. Pi over 6, pi over 3. So where's pi over 4? How much is pi over 4? I got to move it right pi over 4, but how much is that? Well, pi over 4 is half of this distance, right? There's pi over 2. Half of that distance is here. It's 1.5 ticks. So when I want to move right pi over 4, that's right 1.5 ticks. What's the axis? The axis has been moved up 3 to y equals 3. Important points. Well, the b value is 2, so we said the important points occurs every pi over 2 divided by 2, which is actually pi over 4. And again, I could take my 3 divided by my b value, which is 2, every tick and a half. Every 1.5 ticks, I'm going to get an important point. All right, are you ready for this? We're going to see if we can skip through all of the transformations just to the final graph. So how am I going to do this? Well, first of all, I'm going to do some scale here. We said, and there's 3, that it was going to, the new vertical axis, where we would normally have the x-axis, is actually going to be here up at y equals 3. So it's kind of like the graph is going to go back and forth over this y equals 3. Well, how far is it going to go up? Well, we said the amplitude was 2, so it goes up to 5 and down to 1. So that means it's going to be sort of trapped between these 3 lines. Middle line, high line, low line. Okay, dandy. Now, where's the starting point? Well, the starting point was moved right pi over 4. Normally, by the way, a cos function would start at its maximum, right? It would start here, not in the middle like a sine function. It would start at its maximum. But instead, we've moved it right a tick and a half. There's the starting spot. So, you know, a little thick here, but I'm going to say, just put there, start here. Why? Because the cos starts at its maximum, and because of the phase shift in this one, the phase shift, we've moved right 1.5 ticks. That's supposed to say ticks. Does that look like ticks? Sort of. That didn't make that better, but 1.5 ticks is the phase shift, and we did that. Well, how do we know where to go next? Well, we know we're going to, because we're high, middle, low, middle, high, middle, low, middle, high, middle, low, middle, high, and so on. But I got to think about how often those important points are. Since B is 2, remember, important points are every tick and a half. That's why I talked about this important point, why it's so important. Start here, tick and a half, middle point, tick and a half, low. Every 1.5 points, important point. 1.5 ticks, important point. Middle, high, middle, low, and when oops, that was, last one was bad. 1.5 ticks, important point. Now I'm just going from high, middle, low, middle, high, middle, low. Every 1.5 ticks because of the period change. And notice that'll give me, oh, I got to keep going. Sorry, I thought I had been out to 2 pi already. There I am. 1.5 ticks, important point. 1.5 ticks, important point. 1.5 ticks. Oh, now I went too far, but that's okay. And again, don't make it look like teeth. Try and do a nice smooth curve. Now notice there's a little gap here, so I kind of got to follow the pattern backwards. middle, high, middle, right? Tick and a half, important point. And now that's the final graph. Cos of 2 x minus pi over 4 plus 3. Last one. Let's try and do this one real quick. It's a little bit weird, but I'm going to use a green, fill this in. How are we doing for time? Do I need video 3? Yeah, I'm going to stop her and do video 3. If you're good there and you don't need to see the third one, that's fine. I will have this third example in video 3.